Hello students, in this particular lecture we will learn construction of cam profile for a radial cam. So you will see clearly the problem statement in front of your screen. We will try to solve the problem based on construction of cam profile, as it is written here, construction of cam profile. Construction of cam profile, that is written over here. You will see here the construction of cam profile for a radial cam. This particular point, this particular topic that we are going to understand today in this lecture. So what is the problem statement? You will see that the problem statement written over here like this. A cam has to give following motion to a knife edge follower. So which type of follower is used? You can clearly see knife edge type of follower that is used. And let us see how is the motion of the cam. Number 1, outstroke during 60 degree of cam rotation. It means that the outstroke is given for the cam rotation is 60 degree. After that there is a dwell for the next 30 degree of the cam rotation. Third one, return stroke during the next 60 degree of cam rotation. And fourth is dwell for the remaining 210 degree of the cam rotation. So after seeing this data, we can see that outstroke is 60 degree. After that there is a dwell 30 degree. After that there is a return stroke 60 degree. And after that there is a dwell 210 degree. If we add these 60 degree, 30 degree dwell, after that return stroke 60 degree, and after that dwell again 210 degree, then you will get that total addition comes 360 degree. So this is the outstroke, this is the dwell, this is the return stroke, and again this is the dwell. So in this way total angle of rotation of the cam will become 360 degree. So we understood that how is the outstroke, how is the dwell, how is the return stroke, and after that there is a long dwell for 210 degree of cam rotation. So one is the outstroke, one is the return stroke, and two dwells are given in this statement. First dwell is for 30 degree and second dwell is for 210 degree. After that, what is asked, what has been asked over here? The stroke of the follower, is 40 mm. So this 40 mm is indicating the stroke of the follower, and the minimum radius of the cam, this is 50 mm. The cam radius is given, radius of the cam is given 50 mm, and after that it is very importantly given the follower moves with a uniform velocity. So this is the first condition we have identified here. The follower moves with a uniform velocity during the outstroke and the return stroke. As we know, the follower moves as per three conditions. First is uniform velocity condition, second one is simple harmonic motion, and third condition is uniform acceleration and retardation. The most of the problems are based on these three conditions. First is uniform velocity, second one is simple harmonic motion, third one is uniform acceleration and retardation. So this particular problem is based on the follower which is moving with a uniform velocity, this condition that we have identified. After seeing this, after understanding this data, what has been asked, let us see. Draw the profile of the cam when the axis of the follower passes through the axis of the camshaft. This is most important condition given here again. Axis of the follower passes through the axis of the camshaft. This is a condition given the axis of the follower passes through the axis of the camshaft, and as per this condition we have to solve this problem. To solve this problem, always we have to draw first, which is called as displacement diagram. This is called as a first step in creation of cam profile is displacement diagram. And from the displacement diagram we can plot our cam profile. So how is the displacement diagram? How we can plot a displacement diagram? For that purpose, we have to plot first one horizontal line like this. Name this line as A, and this point is nothing but x. Now on this line we have to take the measurement regarding the outstroke, after that dwell, after that return stroke. In this problem, outstroke is 60 degree, after that dwell is going to happen for 30 degree, after that return stroke, that is also given 60 degree, and after that the long dwell is given 210 degree. So this data we are having with us. Now how to plot outstroke on this particular line, A to x. So take a scale. How to take a scale? 1 centimeter is equal to 10 mm, like that. So we have to divide this line in outstroke, dwell and return stroke. So let us plot the outstroke. Outstroke is 60. So here I am starting 0, 1, 2, 3, 4, 5, 6. So this is outstroke. So outstroke, you will see that this is indicating 60 degree, or this is nothing but also called as a rise of the follower, 60 degree. So we have divided this outstroke into 6 equal parts. After that I am naming here the starting point is A and the end point is coming over here is S. So SAS is the outstroke. After that, from this point particularly we have to plot again dwell for 30 degree. So 1, 2, 3, and I am giving here the point number T. So S to T is nothing but a dwell, 30 degree dwell is there, S to T. After that, from this point again we have to give the return stroke. So we have to divide this onwards into 6 equal parts in the same way. So this T is nothing but 0 dash, 1 dash, this is 2 dash, 3 dash, 4 dash and 5 dash, and last one is coming 6 dash. So this is nothing but the last point, which is called as a P. So T to P is the distance which is called as a 60 degree return stroke. So this way the last point is nothing but P, and from P to onwards there is a dwell for remaining 210 degree. So in this way we have seen here the outstroke is given 60 degree, the outstroke is given here is plotted like this 60 degree, the dwell is plotted as a 30 degree, and again there is a return stroke 60 degree, and this is nothing but the dwell for 210 degree on this particular line A to x. So last point is x, and at the end of the x you will see that the 210 degree angle will end up. So this particular region A to S is the outstroke. After that, from this S to T is the dwell, S to T, and from T to P there is a return stroke, and we have divided all this 60 degree, 30 degree and 60 degree outstroke, dwell and return stroke into equal parts. After that, it is given in this problem the stroke of the follower, the stroke is given 40 mm. So for this particular data we have to plot from this point number A a vertical line which is called as AY. AY is a vertical line, and we have to divide, we have to give here the length of the stroke here 40 mm. So this 40 mm is the data indicating the stroke of the follower. Next, what we have to do, we have to plot one horizontal line like this, horizontal line which is parallel to this line a to x completely. After that, we have to start one another vertical line from this point number S. Point number S. S is the point where the 6 equal division end up 0, 1, 2, 3, 4, 5, 6. So 6 and S, these are the same points, and from this point S we have to plot one vertical line like this, one vertical line like this. And in the same way, we have to plot another vertical line from this point number T or a starting point O dash. We have to plot this line like this, and after that from the P point also we have to give one vertical line here like this. So here you will see that we have plotted 3 vertical lines. This is first, and this first line, this second vertical line, and this third vertical line. First vertical line is starting from the point S and 6. Second vertical line is starting from point T and O dash, and third vertical line is starting from P and 6 dash. So here on this particular horizontal line, upper horizontal line, we have to plot this, we have to give the name here. The point number is G. This point after that is nothing but H like this, and this is nothing but the P. After that, what we have to do, we have to do another vertical lines. We have to plot another vertical lines, but very faint lines like this. One passing through the point number 1, passing through the point number 2, this vertical line passing point number 3, another vertical line passing through point number 4, and another vertical line passing through point number 5. And we have to do nothing in the region of this dwell. After that, this is a region which is indicating here the outstroke. So how is the outstroke region? Again, in the same way, we have to plot some vertical line like this. This is the vertical line passing through 1 dash, another vertical line passing through 2 dash, another vertical line passing through 3 dash, like this. All vertical lines that we have to draw. After that, after completion, you will see that here this region is the region for outstroke, and this region is the region for return stroke, and between that the region happens which is called as a dwell. So particularly this region is nothing but the dwell region, and from P2 onwards the region is a dwell region for 210 degree. Now next important step is we have to draw a inclined line like this. We have to join A to G, and we have to join H to P. So why these lines, inclined lines, are straight? Because the condition is given in this problem, uniform velocity. Uniform velocity condition is given. That's why uniform velocity of the follower, this condition is given. That's why we have plotted here one vertical line joining the point number A to G, and another inclined line joining the point H to P. So we will see that some intersection points like this. First intersection point is A. After that, we will give here B, C, D, E, F, and last point is nothing but automatically is matching, that is nothing but G. After that, G to H. After that, this intersection point is I. After that, this is J, this is K, this is L, this is M, and last point is nothing but P. Okay. So this way, this complete diagram starting from this A to G, G to H, H to P, and P to onwards is nothing but called as a displacement diagram. This one is the displacement diagram that we have plotted for this particular problem. Okay. Now from this only, if we are having a displacement diagram, then and then only we can draw a cam profile. So let us see how to construct a cam profile. So here in this particular section, now we will understand how to plot cam profile. cam profile from the displacement diagram. So first step number 1 that we have completed, plotting of displacement diagram. Displacement diagram we have plotted already, and from this displacement diagram, step number 2 is nothing but this cam profile. For this purpose, the simple procedure that I am giving here, first of all we have to give a circle. We have to plot one circle like this, complete circle like this. Then what is the radius? Radius is nothing but indicating 50 mm. Radius, not diameter, you should consider here radius is given. So radius is given 50 mm of the cam, that's why I have plotted one circle here having a radius 50 mm, and I am giving here a center point which is the name is O. So this way I have plotted one circle. Now at the 90-degree angle here, completely at this particular point, we have to plot one follower, and this point is nothing but, this point is origin point, this point is nothing but point number A. So here I have to plot a knife edged follower, because it has been mentioned in here the knife edge follower. I am plotting here a knife edge follower, and you will see that I am drawing one axis line like this. This axis line is passing through the axis of the cam. This condition is satisfied, because in this problem particularly it is mentioned the axis of the follower will pass through the axis of the cam. That is why you will see clearly in this picture the axis of the follower is passing through the axis of the cam. This line, particularly this line, is matching, and this is line called as axis line, and the axis of the follower is passing through the axis of the cam. After that I have to plot here. After that I have to plot different angle. So first angle is angle AOS. Angle AOS is equal to 60 degree, because it is nothing but the outstroke. So from this angle AOS I am giving here S point. So this is angle is nothing but 60 degree. I have to plot this 60 degree angle. So angle AOS is 60 degree, and I have to divide this 60 degree again from the displacement diagram in equal parts. Like if this A is the point, then 0, this 1, this 2, this 3, 4 and this 5. I have equal, and last point is nothing but 6. I have divided this angle into 6 equal parts: 0, 1, 2, 3, 4, 5, 6, and this is nothing but a outstroke 60 degree. Angle AOS is nothing but a outstroke. After that there is a dwell given in this problem. Dwell is nothing but 30 degree. So I have to plot angle SOT. This is nothing but dwell 30 degree. SOT is the angle dwell 30 degree. I have to do nothing division. I have to do no divisions to this dwell. After that there is a return stroke. Return stroke is given 60 degree. So angle TO and last angle is P like this. This angle is nothing but 60 degree, and this angle I have to divide it into 6 equal parts, starting with this 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and last angle is 6 dash. So you will see clearly in this picture, this is nothing but the outstroke and this is nothing but the return stroke, and outstroke is divided into 6 equal parts: 0, 1, 2, 3, 4, 5, 6, and outstroke is also divided into 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and last one is nothing but 6 dash. So outstroke means rise and return stroke is fall, that has been divided into 6 equal parts. Now this is the another important step. We have to plot some lines which are passing through the point number 1, 2, 3, 4, 5 like this. You have to plot lines like this: 1, 2, 3, 4, 5 and 6. In the same way, this is a point, this is a line passing through the O dash. After that 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. You will see that all these lines are passing or starting from the point number O and passing through 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. In the same way, here this line passing through O through 0 dash, O2, 1 dash, O2, 2 dash, 3 dash. So, this revision I have marked like this. After that, from the displacement diagram, you will see that in the previous picture there is a displacement diagram. You have to measure this distance from 1 to 2 like this. You have to measure this distance from 1 to B, 2 to C. With the help of rounder, we have to take all these distances in the rounder. With the help of rounder, we have to measure all these distances and we have to mark this on the cam profile diagram like this. In this cam profile, this is the first distance A to B, this is B point, this is C point, this is D point, after that this is E point and this is nothing but F point and last point is nothing but G point. And from through this all these points, starting point is A, B, C, D, E, F, G. I have to draw one curve, one smooth curve like this. I have to plot one smooth curve like this. And in the same way, in the region of return stroke, I have to plot the lines starting from this 0 dash, the points like this H. So, how to measure this distance? You will see that in the previous picture there is a displacement diagram. 0 to H, after that 1 dash to I, 2 dash, this 2 dash to J, this 3 dash to K, 4 dash to L, 5 dash to M and last point is nothing but 6 dash. So, H, I, J, K, L, M and last point is P. We have to measure all these distance with the help of rounder and we have to mark all these distances in the cam profile diagram. So, here H is the starting point, after that this is nothing but here you will see that there is a J, after that K, there is a L, after that M and after that N and last point is nothing but P. And through all these points again I have to plot one curve like this. So, one curve is plotted here in this outstroke region and another curve I have plotted in the return stroke region, and both of these curves again I have to join with the help of freehand sketch, which is called as a curve joining between the point H and G. So, from this lastly we will found that the complete profile of the cam is like this. Whatever green color you will watching, that is nothing but the profile of the cam profile. This is nothing but the cam profile. This way we can construct a cam profile. Constructed here the cam profile for the uniform velocity condition and the axis of the follower. This axis of the follower is passing through the axis of the cam. So, this way this is nothing but the procedure of how to plot a cam profile. So, here in this if you dark it again, you will see that the picture of the cam is coming like this. So, this is a very simple problem that I hope you understood that one. Thank you very much.